Hey everyone, welcome to day 6 of programming every day until I'm employed. Um, let's just get into it. I think I'm on this one. Yeah. Okay. Keyword working. Oh. We're given an array of strings tokens. Operators follower. Okay. So gonna set up a result variable, and then we want to use a stack here because the operators follow their operand, so we want to stack to get the operand, I think. Let's just draw out a few examples. I'm pretty tired because I've spent like this whole day writing my essay for graduate school, so hopefully I can power through. Truncates towards 0. So this second one is going to be a little tricky. So I guess every time we reach an operand or operator, we pop the first two values off the stack. So right here we reach this, so we pop these two, complete this operation, and then we take the result of that and add it. So damn, I'm tired. 2 1 plus 3 multiply. Wow, that looks terrible. Actually, I think. Be right back. See how this works. This is a drawing tablet I just realized I had laying around because my brother used it. So my drawing tablet is also somewhere. I just have no idea where. So it'd be pretty useful for writing out these or drawing these things instead of using a mouse, because it's very tedious. Okay. What? I'm gonna reinstall this. This is so annoying. Okay. Oh, there we go. Sorry, guys. So like I'm confused. Okay, there we go. Okay, it only works on one stroke, and then it stops. What the fuck? Is it my driver? No, because it stops with this as well. Okay, I guess I'm just gonna be using this. What the fuck is the eraser? Okay. P and E. Okay. So, okay, sorry about that. 2, 1 plus 3 star. 1 plus. So we have a stack, so we would first add 2 to the stack, then we add 1 to the stack. We get the plus, so then we pop these two. So let's say x, y equals 1, 2. So now the stack's empty, and then we would add these two and push it to the stack. So then 3 would go here. Then we get to 3 here. We push 3 here. Get to this. Do that operation on these two, and we get 9. So if we go here, okay, yeah. So it's equal to 9. What about 4, 13, 5? I'll go back in a sec. 4, 13, 4, 13, 5. Divide plus. And this truncates towards 0, the divide here. So we have our stack 4 and 13, and then we 5, and then we get here, we pop these two, divide them. So x, y equals 5, 13. And you do 13 over 5, right? Yeah. So we would take the second one, divide by first, which equals 2. Let's also go ahead and pop these from the stack. And then we push the result 2 into the stack. So we go 2. And then we have plus, so we pop these two. 4 plus 2 equals 6. And then pushes to the stack 6. I guess we do a for each loop. I think we do a for each loop here. And then I guess we return the stack at -1. Okay, sounds good. Let's go ahead and cut out the question. So just take this away. So we don't even need this result variable. Let's just go ahead and initialize the stack, and then for E for element and tokens, we're gonna what do we do? So we if E, let's just make I think it's the curly brace, yeah. Set or ops equals plus minus star and divide. Okay, so if E not in ops, stack dot append E, else x y equals stack dot pop stack. Let's just, so for minus, do they have a minus? Okay, so we do y and then the operator. If, dang, do I have to do a conditional for every single one? Can I convert? Eval not recommended. Using a dictionary. So import operators equals dot add. Okay. Okay, so we do operator.add, operator.sub. So this will be a hash map. true div. More. If he is not okay, so that's how you do it. Oh, but these are all strings. How do you cast in Python? See if this works. Oh. 2.6. So div. Operator.trueDiv for wait. Floor div. Oh. Okay. Yeah, I know I'm getting that one wrong, but let's see. Jeez. Okay. Let's see what the fuck was wrong with this one. Dang, I honestly thought I had it all mapped out again, but obviously not. Dang, these numbers are so. Okay, I'm going diagonal. So stack 10, 6, 9, 3. 9 plus 3 is 12. Remove these two. Add 12. Negative 11. Multiply 12 and negative 11. Negative 3, 2, 1. Oh, 1, 3, 2, sorry. Divide these two. 6. Huh. What does that even give? 0? Negative 0? Okay, well, it's telling me how to do it. This is what I'm doing, taking the last two, adding the result to the stack. What? Dang. So what's wrong with this? turning 12? Oh, fuck. Keys? I don't know if that changes anything. Nope. How about I just do it here? And then I don't have to do this. Oh, brother. Oh, brother. How can I get 12 from here? Genuinely, I don't know what's wrong. I'm gonna have to watch the video.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem evaluate reverse Polish notation. Quite a mouthful, but basically this problem is about what the meaning of that term even means, and it's just kind of a way to compute arithmetic expressions, and the only operations we're really going to be doing in this case are going to be the simple ones: add, subtract, multiply, and divide. One note that they tell us though is division between two integers should basically round towards 0. Since I'm going to be doing this in Python though, if you take some values and do integer division between them, they always round down, which is not rounding towards 0 necessarily, because imagine if we had -3 divided by 2, that's -1.5. It rounds down to -2 in Python, but that's not what we want to do. But there's a trick in Python that you can do to make it round towards 0, so we can take care of that. If you're using Java, though, I think it automatically rounds towards 0, same with like C++ and most languages. One thing we're told, though, in terms of the RPN expression, is that it's always going to be valid, which is good, so we don't really have to worry about too many edge cases. There's never going to be some divide by 0 or anything crazy like that. So now what...
Okay, yeah. So if it's negative, if it rounds down, then
what does RPN even mean? Well, let's take a look at this example. So we're given a 2, a 1, then a plus operator, then a 3, and then a multiply operator. Now, the way this is going to work is we're going to be reading from left to right. We're going to be reading the inputs. So the first one was a 2. Next one is a 1. When we reach an operator, though, what exactly are we supposed to do? Well, any operator in this case is going to be applied to the previous 2 values. And like I said, there's not going to be edge cases, so we're guaranteed that there are going to be 2 previous values. So in this case, what we would do is replace this 2 and this 1 by adding them together. So it's going to be replaced with a 3, right? So we can kind of forget these, and we already used this plus operator, so we can kind of cross it out as well. Now we have a 3 again, so I'm going to be kind of writing it down here just to kind of, basically say that we've seen that 3 before. Now we have the multiply operator. It's going to be applied to the 2 previous values. Now, in the actual input itself, you can see that the previous value was a 3, and the value before that was a plus operator. When we say it's going to be applied to the 2 previous values, that's not what we mean. We don't want to apply it to another operator, right? We mean the 2 previous values that came. So you can see that we had a 3, and then the one before that was a 1. But remember, this 2 and this 1, they were replaced by this 3, and then we had a second 3, which we wrote down here. So this multiply is going to be applied to these 2 values. So we can multiply both of them and then replace them with the result, which in this case is going to be a 9. So you can see that that is our result, and you can see that it is correct. If you know the data structure, or you're familiar with the data structure, a stack, and you've used that in other problems before, I think this problem is pretty simple to figure out that a stack will be useful here, because basically each operator is going to be applied to the previous values, right? But in the case of this 2, the previous values are going to be removed from the stack, right? And then replaced with the new value, which is a 3. So, as we read through the input, each value here is going to be added to the stack. Anytime we reach an operator, the previous 2 values are going to be removed from the stack, and then we're going to do the operation on them. So in this case, 2 plus 1, and then we're going to take the result of that, which is 3, and then push it back onto the stack. And that's kind of what I was getting at when I was doing the drawing explanation. So really quickly, let's actually run through an example with a stack. And just to make this problem a bit more interesting, let's replace this plus operator with actually a subtract, and this multiply with a divide, because it's going to be a little bit different with these 2 operations, because with plus, these 2 are going to be added, right? 2 plus 1. But when you have subtract, which order are they going to be subtracted? Well, the intuitive one would be 2 minus 1, because that's the order that they appear in. But 1 minus 2 could be possible, right? Well, in this case, if you looked at the second example, I think they clarify that, yes, it's going to be this way, right? 2 minus 1. Let's run through this with a stack very quickly. So we read the first value, it's a 2. We add it to our stack. Second value is a 1. We add it to our stack. Next, we get the subtract operator. What does that mean? That means we pop these values from our stack and then do the operation. So in this case, it was 2 minus 1. That's going to be a 1 over here. Next value is a 3. We add it to the stack. Next, we have a divide operator.
check. Does that actually work? Oh shit. What the hell? Okay, so that does work. Forgot to cast it to an int. Okay. So that Okay, so double is that this? Okay.
So
Let's
in this
just see
case,
how he
it's
does it.
statements. The first one is if the character is simple. It's going to be very similar to what we do in our divide operation down here. We're going to pop two values, and then in that same order, B and then A. So just a bunch of boilerplate. But once all that's done, let's go ahead.
Okay. Well, he did a bunch of conditionals, which I did not want to do. Okay. Let's move on to the next one. Okay, I remember the daily temperatures one was low-key confusing. I think you had to use something called like a monotonic stack. Which I definitely don't remember. So I have to be looking at that. Damn, 76 acceptance rate. Loki, I think you need like recursion for this. Um, given n pairs of parentheses, generate all combinations of well-formed parentheses. So n equals 3, we have I honestly think you need recursion. Or I don't know, there has to be a different way, right? Okay, I'm gonna give myself 15 minutes to try and figure this out. So 12 a.m. Honestly, I don't think I know how to do this. Hopefully, I'll figure it out. But some stuff. Sorry, I just zoned out for a sec. N equals 3. This acceptance rate is so high, though. Like, I was thinking maybe we just go from like 3 and then 2 and then 1, but it doesn't make sense for there to be 3 answers. How many are there here? 1, 2, 3, 4, 5. So how many permutations can you even get, like, make? So there's only one possible for 3 in front. Then there's 2. There's 3. There's 2 possible for 2 in front. What? Okay, let's try to. Recursion. Let's see if I remember. Recursion. This is bad. Let's do a base case, right? So if but that's not like a stack, is it? Or am I tripping? Add equals 1. Dang. Wait, I did need a result. Sorry. I think I just have to watch the solution.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve generate parentheses. So we are given a pair, a certain number n pairs of parentheses, and we want to write a function to generate combinations of all well-formed parentheses. And so you can see that these are the examples, and by well-formed, they basically mean like when you're writing code, you're nesting parentheses, you want them to be nested in a valid way, right? Like we can't have a right parenthesis come before a left parenthesis, right? Like this could not be possible. We would have to do it like this, right? So you can see for each left parenthesis, we have a matching right parenthesis that comes at some point after it, right? So like in the first example, the first 3 are left parentheses, then the next 3 are right parentheses. And when they say n equals 3, that means we have 3 pairs of parentheses. So in total, we have 6 parentheses because a pair is 2 parentheses. And 3 are going to be open parentheses, and 3 are going to be closed parentheses, right? So this is a open parenthesis, this is a closed parenthesis. You can see that when n equals 1, there's only one possible way to make them valid, because this is one way and the other way would be this, and we know that this is invalid. So how can we solve this problem? Let's just try out the backtracking solution, kind of, right? Like a sort of brute force approach. How would we even do a brute force approach? Let's say n equals 3, so then we... we have 3 parentheses. What does that tell us about valid parentheses, right? Like this is one valid parenthesis that satisfies this condition, right? We have 3 open parentheses, 3 closing parentheses. Well, the first thing it tells us is that we need 3 open parentheses and 3 closing parentheses, right? That much is pretty obvious, right? Like you could probably figure that out by yourself. If we have 3 pairs, then we definitely need 3 open and 3 closing parentheses. So in total, 6 parentheses. But what about the order of parentheses? So let's say so far I'm empty, right? We're empty. Can I start out with an open parenthesis? Yes, I can, right? But can I start out with a closing parenthesis? No, we know that this is invalid. No matter what I do now, this is always going to mess up our parentheses. So we can't start with a closing parenthesis. We can only start with an open parenthesis. Okay, but now let's say I have 1 open parenthesis. Now what can I do? Can I have another open parenthesis? Yup, because our limit is 3 open parentheses, and so far we have 2, so we're allowed to do that. What about a closing parenthesis? Can I have a closing parenthesis? Yes.
Bro, it's not that hot.
Because so far our open count is 1, And initially the closing count is 0, and I can, by adding this parenthesis, I'm just changing the closing count to 1 now, right? So now let's look at it. Now can I add another open parenthesis? Yes, I can, because the limit is 3 open parentheses, and so far we only have 1, so I'm allowed to add a open parenthesis. What about a closing parenthesis? Can I add a closing parenthesis right now? No, because you see that so far we have one pair, right? This pair of open and closing parentheses, and then when you get rid of that pair, then we're just left with a single closed parenthesis. This closing parenthesis will never have a matching open parenthesis on the left of it, so we can't add this parenthesis. And how would you figure that out from code? Well, just
那个杯拉明天来吗？
Yeah.
吃晚饭是吧？
I'll ask.
Okay.
I'll ask.
just take a look at the count we have so far. Before we add the parenthesis, we have a count of 1 for closed, we have a count of 1 for open. Basically, what this tells us is that we can only add a closing parenthesis if the count of closing parentheses is less than the open count. We can only if this is true are we allowed to add a closing parenthesis. So if, for example, if I were to add another opening parenthesis, now we update our open count to 2. So now we have 2 open parentheses, right? So 2 is open, 1 is closed from over here, right? So now I'm allowed to add a closing parenthesis, right? So basically, let's say if we're going to do backtracking, these are the 2 rules that we have to follow. This is basically our base case. Once we have 3 open and 3 closing parentheses, then we have a valid parenthesis formation, right? And this condition tells us when we're allowed to add closing parentheses. We can add as many open parentheses as we want as long as it's under the limit, which is n, right? We can add up to 3 open parentheses, but we can only add a closing parenthesis if the number of closings so far is less than the number of open parentheses. So with that said, let's start our backtracking solution. So far we're empty, right? So the first thing we're going to do is add a open parenthesis. So now this is what we are so far, a single open parenthesis. Since we added a open parenthesis, that means the count of open is greater than the count of close. So now we have 2 choices. We can add a open parenthesis or we can add a closing parenthesis. So we have potentially 2 open parentheses or a single open and a single close. Okay, let's take a look at this decision. Here we have open is greater than or equal to close, right? And the number of open is still less than 3, so we can do both choices. So from here, we can add another opening parenthesis, so we have potentially 3, and we can add a closing parenthesis, so 2 open and 1 close. From here, we see that the open and close count is actually equal, right? We have 1 of each. So here we don't have any choices. We have to add a open parenthesis. So what we're going to do is have just another open parenthesis come after. Okay, so I'm running out of room, but let's continue. So over here, now we have 3 opening parentheses, right? So we reached our limit, which is n. So we can only make 1 choice, and that's to add a closing parenthesis. So we're going to have 3 open and a single closing parenthesis. Here you can see that we have 2 open parentheses and 1 closed parenthesis. So we can actually add, we have 2 choices. We can add an open and we can add a close. So if we add an open, we'll end up with 2 open, 1 close, and then another open, or we'll end up with 2 open parentheses and 2 closing parentheses. Over here, we also have 2 choices because we see we have 2 open parentheses and 1 closing parenthesis. So if we add a open parenthesis again, we'll end up with open, close, open, open. If we add a closing parenthesis, we will end up with open, close, open, close. Okay, so we're almost done. Starting over here, we see we have 3 open parentheses, so we can only add a closing parenthesis now. So open, 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 close, close. From here, we actually only have 1 choice, even though we have more open. We have 3 open and 1 close, which open is more than close. So we should be able to add 1 of each, but we can't because we know that 3 is the limit, so we can't add any more opening parentheses. We can only add a closing one. So the new parenthesis we add is closing. Here we also have 1 choice. Even though we only have 2 open and 2 close, we know that the open count is equal to the closing count, so we can't add another closing parenthesis because that would make it invalid, right? So we can only add a opening parenthesis, so we'll just add a single open. Here we also only have 1 choice because we already have 3 opening parentheses, so we can only add a closing parenthesis at this point. Here we also have 1 choice. We can only add a open parenthesis because if we add a closing parenthesis, that would make this invalid because then the close count, which would be greater than the open count, right? Which we cannot do. And so at this point, for each of these 5, we only need to add a single more parenthesis, and since this has 3 open, 3 and 2 closed. We know that we need 3 of each, so the only thing we can do is add another closing parenthesis to it, right? So this is going to be one possible solution because now we actually have 3 of each, which is what we wanted. For this one, we have 3 open and 2 closed, so lastly, we are going to add another closing parenthesis. And you might notice that's what we're going to do for each of these, right? Because each of these now has 3 open and 2 closed, so all we need to do is add another closing parenthesis. And for this one, we also are just adding a closing parenthesis. And lastly, this one, we're also adding a single closing parenthesis. So now if you look at all 5 of these, you see that they're all valid, right? And you see they have 3 of each, and they come in a valid ordering. So these 5 are going to be returned as our result. These are the 5 ways we can make valid parentheses. So now let's finally write the code. This is basically what we're going to do. You can see I summarized it. So we're only going to add an open parenthesis if open count is less than our input n. We're only going to add a closing parenthesis if the closed count is less than open. And we're only going to stop adding parentheses altogether once our open count equals our closed count, which is going to equal n. So I'm going to do this recursively because that's basically the best way to do it. And I'm going to create a stack, which is going to hold our parentheses. And I'm going to create a variable result, which is going to have our list of valid parenthesis combinations.
Stack to hold the parentheses? I'm a little confused on that.
And I'm going to do this recursively. So I'm going to put a function backtrack inside of. So I'm going to do this recursively because that's basically the best way to do it. And I'm going to create a stack, which is going to hold our parentheses. And I'm going to create a variable result, which is going to have our list of valid parenthesis combinations. And I'm going to do this recursively. So I'm going to put a function backtrack inside of another function. So if we have this, then we don't need to pass in these 2 variables into our function because this is nested inside of here. We also don't need to pass n into this function either. But we are going to have to pass in our open and closed count. So I'll call that open n and closed n. So we know the base case is if open n is equal to closed n, which is equal to n. So in that case, we have finished, and basically our stack will contain the proper parentheses. So what I'm going to do is basically some Python stuff, but you could probably handle this with a string if you wanted. You don't actually need to use a stack, but I just like doing it. So what I'm going to do is take every character in the stack and join them together into a empty string. So once they have been joined together, they will form a complete string. And what I'm going to do is append that.
What?
To our result list. And once I've done that, I can just return, right? Because this is our base case.
Global stack.
Remember, if we want to add a open parenthesis, we have to check that our open count and a open parenthesis. So just an open parenthesis, and then we can recursively continue our backtrack. Open to our stack, we can append a open parenthesis. So just an open parenthesis, and then we can recursively continue our backtrack. But if we do that, we have to increment our open count by 1, and the closed count remains the same. And after that backtracking returns, though, we do have to update our stack because we only have a single stack variable. Remember, we're not passing the stack into every single call. This stack is basically a global variable. And then we can replace less than n. If that's true, what we can do is to our stack, we can append a open parenthesis. So just an open parenthesis, and then we can recursively continue our backtrack. But if we do that, we have to increment our open count by 1, and the closed count remains the same. And after that backtracking returns, though, we do have to update our stack because we only have a single stack variable. Remember, we're not passing the stack into every single call. This stack is basically a global variable. So every time we're done with backtracking, we're going to pop the character that we just added to the stack. And if we want to add a closing parenthesis, we have to make sure that the closed count is less than the open count. So then we can take our stack and append a closing parenthesis, and then we can call our backtrack function, our recursive backtrack, except we'll leave open count the same this time, and we'll actually increment the closed count. And as before, we're also going to need to clean up, so we're going to have to update our stack by popping the character that we just added. And this is actually the entire here, and I export our backtrack function. Back is initially a valid 0. So the only thing we have to do now is call our backtrack function, pass in 0, return these. So as you can see, this solution works.
Okay, well, the coding kind of makes sense, but I don't understand how I don't fully understand the backtracking. Like, I kind of get some parts of it. I don't really understand how you can hit every single possible combination by appending and then popping. So if you append something, then you call n+1. Oh, I guess if you do the recursion, you would hit the recursive function before popping. I don't really get this backtracking, like the whole thing, to be honest. Like, this makes sense, but at the same time, I don't understand how it's possible, like how that code makes it so that it hits every single combination. It's like if you append this, you call it again. Wouldn't you append this again, call it again? So wouldn't you do you would do the first one, and then you would go again, return. Okay, so we return from this, and then we call or return result. Okay, to be honest, I'm not like super worried about this problem right now, cause what the fuck? Cause everyone says it's like fuck. I didn't get everything in it. Everyone says it's like backtracking, which I know I'm ass at, and fuck, where's chat? And I haven't practiced it yet, so I'm not too worried about it right now. But I do want to understand it a bit more, so I'm gonna try to understand it a bit more, and then do a little bit of the text editor again before I sleep. Yeah. Oh, backtrack by removing the last element. The fuck? That's 3 pairs. Damn, my back hella itchy. Okay, I honestly don't get it. This might just have to be a thing where I kind of memorize the general idea of it, but I don't fully comprehend it. Um, yeah, I might. I don't know. I'll see what I do about it when I reach it later. Is there backtracking? Yeah, there is a backtracking. Is this problem not like literally a permutation? Um, Whatever. I'll probably search up resources to help me with it once I get there, but for right now, I'm not gonna worry about it too much. I'll like kind of get it, which is good. Fuck. It's the global stack. If open equals close equals 3, return. Oh wait. Res append. backtrack with +1 close stack.pop to backtrack. If close is less than open, then we stack append the close backtrack. So outside of the function, oh fuck. Outside the function, so we call backtrack 0, 0, return res. Oh my god, I did the wrong thing again. Damn, boy. Oh, fuck. Whoa. I did that number controlled this whole thing. Well, it would make sense, but what the? Oh, fuck. Okay. That's enough for that. So I think I do remember these two being kind of tricky. Hopefully I'm able to get it. Binary search shouldn't be too bad. Fuck, what'd I do? Yeah, hopefully it's not too bad. Let's work on this a little bit. Cooked mode. See if I remember how to use NeoVim. I mean, is low key. Ooh, my resumes. Text editor. Fuck. What? Why'd it go full screen? Whoa. How do I run this again? CC? Not good, guys. Oh yeah, I guess I could run the makefile, right? Let's try it here. TC get. What the fuck did I just do? Turn me OS dot. What? How do I... Whoa, okay. Address of all. What is this at you? Ampersand equals bitwise and. Oh. Each key you type to be printed to the terminal. Okay. Save. so that exit. Okay, we use it to register our disable raw mode function. iCannon. C-type page. Okay, I think I'm gonna go to sleep. To be honest, I don't know how much use it is for me to learn this in depth about how the terminal works, but I guess it's pretty cool. I mean, I'm learning a good bit about the terminal. So yeah, I mean, it's pretty cool. Alright, I'll see y'all in the next video. Peace.